This video covers importing files and putting them into data frames. Before looking at that, you'll need to understand what a data frame is and how to interact with a data frame on a very basic level. Much of the power of data analysis comes from working with big data sets, so we'll often be importing information and putting that into a data frame to make it easier to work with. The Pandas library provides functions that handle most of the common file types for this kind of work. A very easy file format for exporting and importing tabular or structured data is called a comma-separated values file, or a CSV. A CSV file is just a text file in which each line represents a row and each value in a row is separated by a comma, which is where the name comes from, obviously. The data I used in my video on introductory data frame concepts would look something like this. And if you were to display that as a data frame in Jupyter Notebooks, this would be how it renders on the right. So you can see that each row in the data frame is one line of text in the text file. And the columns are delimited by these commas. So every time there's a comma, it starts a new column. Pretty straightforward. You can create a CSV with any text editor like Notepad or TextEdit or in your IDE. By convention, a comma-separated file should have a .csv file extension. Visual Studio Code, incidentally, has an extension that will apply some nice color coding and some other, helpful things if you're really working with CSV files on a regular basis. But another easy way to get a CSV file is to use Excel or some other spreadsheet application and then export that data as a CSV. It's a really common export format for most spreadsheet applications. A similar kind of file is what we would call a tab delimited file or a tab separated file. It works the same as a CSV, but it uses tabs instead of commas. So here's what that might look like. So same idea as with the commas, one row per line, but instead of having a comma between each data element or separating the columns, basically, we have a tab. And this makes it a little bit easier for humans to read. You can see, though, that it does get messed up if the data inside of a column is bigger than the sort of tab stops. It gets a little bit messy, but it is a little easier visually for people who are looking at it. Python, of course, doesn't care if it's easy to look at. It will process it just the same either way. And again, you can create this in any of your favorite editors. Just type in your data, hit tab, and type in the next piece of data. When you get to a new to the end of the row, you just hit enter and keep going. Tab delimited files often have just a txt extension. That's what I've used here. You do sometimes see them named with .tsv, as in tab separated values. I don't think that's quite as common, but either one is considered acceptable. And again, exporting these from Excel is a really common way to create a tab delimited file. It's a real common export format that we use. And in fact, Pandas can actually import Excel files directly, so you don't even have to export your data if you don't want to. We'll try importing all of these in this video, and there are many other types of file types that Pandas will import without any extra work on your part. After you've seen how a few of them work, you get the hang of it, and it's pretty straightforward from there. I have links to the files that I'm using in the description for this video in YouTube, as long as I remember to put that link there, but it's also in Canvas. So you can download those and extract them, or you can just go create similar files in Excel and export them into the different formats that we're going to try here, CSV and tab separated. Once you've organized yourself with those files, you can come back and we'll jump in and see how to import them. All right, so I'm going to get started, as I always do, by importing that pandas library. And I'll alias it to PD. Now, I've run my notebook once before, so everything's set up and ready to go. You may need to select a kernel, and the first time you run it, it takes a little bit longer than usual. Mine's all ready to go, so it's compiled and operational. When I'm ready to create my data frame using this imported data, I'm going to say df CSV. I'm going to call it df CSV, as in this is my data frame from a CSV file. And all I need to do is call a function in the pandas library called read CSV. And it does exactly what the name suggests. It reads from a comma-separated values file, and it will return a data frame once it has processed that. As an argument, we provide the file name. Now you can see over here in my Explorer that I have my data files in the same folder as my Jupyter Notebook, and that makes it easy. Then I can just type the file name in quotation marks. But it's okay if I don't. If yours is somewhere else, if it's in maybe your downloads folder or something like that, we just need to specify a full path along with our file name. The way that we do that is going to be a little bit different depending on your operating system. Now, if I'm in Windows, then this process is going to start with finding the file in my File Explorer. And just so you know, this wouldn't be helpful, because if I can do this, then I already know where the file is. But if I right-click on a file in Visual Studio Code, for example, there's an option to reveal that file in File Explorer. That will take me directly there. Many applications, many IDEs have that. I think more often the idea is that you are not sure where it is, or you need to go kind of find it, you need to go track it down. So in my case, it's on my Google Drive, and it's in a folder called CIS 256, and it's this first file right at the top. So there are two really easy ways I can get this file path. So one of them is on the address bar at the top of my File Explorer. If I click that, it changes the graphical display of my path down to a text display. In this case, g:/my drive/CIS256. I can copy that and then go back to my code and paste it in. And now all I need to do is add another backslash and then my file name. And I should be ready to go. The other thing I can do makes it just slightly easier is if I click on my file in the File Explorer, and if I now hold down the Shift key on my keyboard and right click, one of the options is copy as path. Now if you don't hold down the Shift key when you do it, that option doesn't appear. So you have to toggle that on by holding Shift. And then I'm going to say copy as path, and that gets me the entire file path, basically the path itself and the file name tacked on. It adds quotation marks onto the end of it. But now I've got my full file path, including the file name, ready to go. If I'm working in Mac OS, it's a very similar process. Once again, I still have that ability to right-click on my file in Visual Studio Code and reveal in Finder. That's the Mac equivalent of File Explorer. So I could do that. I can also just open Finder, navigate to that file's location, and retrieve the path from there. Now for this to work, you need to have a path bar displayed at the bottom. There's another way to get it, but the easiest way is if you have the path bar displayed at the bottom. If you don't, you're just going to go up to the View menu, and you can toggle that off and on by saying Show Path Bar or Hide Path Bar. And I'm going to turn on my path bar. I'm going to select a file here, and now you can see very much like Windows File Explorer, it shows a kind of graphical representation of the entire path to that file. If I right click, then the very last option is copy that as a file, a path name. So I'm going to go ahead and click that, come back to my code, and paste that in. So we're in good shape now. I've got a full file path, so it should work whether or not I have the file in the same folder that I'm working in. But we've introduced the possibility of a problem here, and that is that our fully qualified path name might have some symbols in it that will trip up the interpretation of where that is, especially in Windows where you have like backslashes, right? So you can solve that by going and kind of changing those so that they're neutralized in the escape sequence by adding slashes. But we can also just tell the method that I would like to just take this string as is instead of processing what's inside of it. And we call that a raw string. And so the toggle for that is to put an R right before the string. And that tells Python, that tells the read CSV function, don't worry about what's inside it. Don't try and figure out something fancy with it. Just take it as it is and use it. The only thing you got to be careful here is to make sure you put that R not inside the string, but right in front of it. Now, using the raw string does no harm, even if you don't need the full path, like in my situation. And just because we don't need all that on my screen, I'm going to get rid of all of that because my file is right here in the folder I'm already working in. So I don't need to fully qualify it in that way. So let me run that and just make sure I don't get an error. I don't see any output, but it hasn't produced an error, so that's a good sign. Let's go ahead and render the result here. And there is my data frame. It looks very much the same way it would look if we created it ourselves, and in fact it is the same. It is a data frame object, and you can interact with it in all of the same ways. The only difference is I didn't have to type in all of that data myself, and that's obviously a good thing. So that's the basic idea of how to read from a file and convert those contents into a data frame. Other file formats are going to work pretty much the same way. Let's take a look at a tab delimited file. In this case, I'll call it DataFrames, DataFrame tab. And for this kind of a file, Pandas provides a function called read table. And so if I pass in the name of my file, so once again, if it's not in the same folder as your notebook, you'll need to fully qualify this with a complete file path. Mine is right here, so I'm going to say car data tabs.txt, and it's being friendly and offering it to me. And then we'll output that and render that and see what it looks like. And it looks like it worked fine again. So no big deal, right? It works exactly the same way. There is one little twist we can show you with a tab delimited file here, just to show you some of the flexibility that we can do. Another way that I can get that tab delimited file into a data frame is I can still use that read CSV function with that file name. So car data tabs.txt. If I just do that, let's see what happens. If we give that function a tab delimited file instead of a comma delimited file, I get kind of a mess. It didn't understand where the tabs, what the delimiters were, and so it rendered the tab characters and it didn't use them as separators. But what I can do with this read CSV file is I can give it an argument. I can pass in as an argument what my separator is. And so it's called the SEP, the SEP argument. And I can just say that, well, it's going to be a \t, which is the escape sequence for a tab, right? And that's why it rendered it that way down below. And let's try that. Now we're back in business. There's not really, I guess, a compelling reason to do it this way versus using the read table function, but this does give us some flexibility because maybe you have some file that is separated with something other than a comma or a tab, and those are by far the two most common, I think, but Maybe you have a file that's where the data is separated by spaces or by the pipe character, which is that vertical line. Sometimes you might see some of those. So if that's the case, I can still just use this read CSV and put in whatever character is going to be separating that for us. So it just gives us an added level of flexibility. The tricky thing about data sometimes is that we don't often get to choose what format it comes in, right? It might come to us as some weird thing that was easy for the programmer on the other side to produce and not meant to be easy for us to consume. So just another option you have at your disposal as you're working with these kinds of files. And the last one we'll look at here is importing from an Excel file, just because that's a real commonly used file and it's something that students can work with easily. You probably have experience using Excel, at least on a basic level. So it's good to know how to work with those files as well. So there is, as you would expect by now, there is going to be a function that will help us with that. So I'm going to do df xlsx. And we're going to call read Excel, right? So read underscore Excel, and same deal here. Mine now is called car underscore data dot xlsx, and that is the current standard file extension. If you have an older Excel file, it's going to be in .xls, but that's many years ago now. So most of your files should be in this newer format. And let's go ahead and run that. You can, I can already see it's taken a little bit longer to process all of that. An Excel file has a bunch of other metadata in it besides just the simple, what we would have is a simple text file with just the data. But the result is the same. Eventually it's able to process that and pull it all in. And it's worked just like our other functions have to this point. There is one other wrinkle or twist on this that is worth explaining, and that is that in Excel files, we often have multiple sheets, right? The tabs down at the bottom of your workbook. And so maybe you want to pull in from a different sheet. Well, this read Excel function by default is going to pull in whatever the first sheet is, meaning the one that's farthest on the left. Maybe I want to get a different one. I didn't think to put any additional sheets in my sample data here, so I'm not really going to be able to do this, but I can pass in an additional argument here, sheet name equals, and then whatever the name of that other sheet is. And so by default in Excel, they're going to be sheet 1, sheet 2, sheet 3, and so on. But even if I've renamed it, I can specify whatever that renamed identifier is, and that will let me pick which sheet I pull from. This is important to know because if I want all of the data in the entire Excel file and it's split across multiple sheets, I'm going to have to pull those each in separately, and they're going to be in separate data frames. I suppose I could then go and convert those into one data frame if they really are meant to be together, but I'll have to handle that myself. So that's worth knowing about Excel and that read Excel function. There are other functions for some different file types. Another really common file type that you'll interact with if you do this for any length of time is going to be a JSON file, just because that's a really common format that's used to share data. And especially in analytics, a lot of the data that we pass around is in a JSON file. So there is a function that shows that. There are a bunch of others. I'm not going to go through all of those because they all work essentially the same way. And if you get to the point where you need to import some of that data, you'll be able to figure it out without too much trouble. Importing these files gives us a real flexible way to gather up a potentially large set of data without having to type it all in ourselves, and that's obviously important and helpful. And that idea of having big amounts of data to look at and to analyze and to visualize, that's really where the power of data analytics comes from. So this is an important step as we are learning how to get into analytics here. If you have any questions about importing these kinds of files, be sure and reach out.